everyone, let's take a look at this 5 for 5 assignment that covers a variety of topics from Unit 7. So we're looking at slope fields, differential equations, that kind of thing. And it wouldn't surprise me if some of this stuff was a little rusty. It's been a little while since you've seen some of these types of problems. So that's the intention with this assignment, is for you to kind of refresh yourself before you come back to class and we talk through some of the bigger ideas in this unit. So starting out here with number 1, first question is find a solution to a differential equation. And let's just refresh ourselves on terminology. Differential equation just means an equation with a derivative, right? So this is a derivative equation, okay? The solution to a differential equation then is talking about an antiderivative. And if it asks you for a general solution, which this question doesn't, but a general solution just means it's going to have a plus c in it. In this particular problem, we are finding what's called a particular solution because we have an initial condition, and that's going to let us solve for c. Okay? But antiderivative is our goal. Now, if this equation just had an x in it, we would just do a plain old antiderivative. In fact, they probably wouldn't even mess around with this fancy terminology. We would just do an antiderivative. Where things get tricky is when you have y's involved. And when you have that y involved, you end up having to do a process called separation of variables. So our goal is to split up the dy and the dx. So dy is going to stay put and dx is going to move over to this side. And then we want to move the y's over with the dy and leave x's over with the dx. Okay. So I'm going to start by dividing by y squared on each side. We can think of this as having like a 1 over here. So when I divide by that y squared, I end up with 1 over y squared. And remember, we said we're going to leave the dy hanging out over here. Now left on this side, the y squared is gone, but we should still have the 3, but we're going to multiply on this side by the dx. So we'll have 3 dx. So I've separated the 3 from the y squared, dy on one side, dx on the other. And remember, our mission was antiderivative, right? So now that I have y's with y's and x's with x's, I can do integrals. Because I can integrate this in terms of y, I can integrate this in terms of x. Now, that 1 over y squared, I'm going to rewrite that, and I guess I'll jot it up here. But this is really y to the negative 2 power. That 1 over y squared is y to the negative 2 power. So when I do my antiderivative, I'm adding 1 to that exponent. So that would become y to the negative 1 power. And then dividing by negative 1, which is just going to put a negative 1 out front, because it's like 1 divided by negative 1. So that's my antiderivative. Equals, and then the 3 when I do an antiderivative becomes a 3x. And the x side is always where I put the plus c. Remember that c value, like technically there would be a c on both sides, but I've just like collected all the c values over on the right. So that c represents the constants from both sides. So what I always do with these problems is right here, before I move any further, I'm going to pause and I'm going to go solve for c. I want to figure out what this value is. Okay? So I'm going to do that using this initial condition up here. And the initial condition, remember, this is your x value and this is your y value. This thing here, the negative 1 over y to the negative 1 power, I am going to rewrite that as negative 1 over y. I think that'll make your life easier in a minute. We'll come back and do some more stuff here. But so now I have negative 1 over my y value, which is 3, equals 3x, so 3 times 0 plus c. And then 3 times 0 goes away, so really what I just figured out is that my c value is negative 1/3. And I'm going to take that negative 1/3 and put it in place of that c value before I carry on. So that's what I'm going to pick up with here. So I have negative 1 over y equals 3x minus 1/3. These next couple of steps get a little bit gross. probably the easiest thing to deal with here is this negative sign. Let's move the negative sign to the other side. So when I do that, this will become a positive 1 over y. And then the 3x becomes negative, and the 1/3 becomes positive because I distributed that negative. Okay, and then there's a few different ways you could handle this from here. But what I would do is just say, hey, I really wish I could take that thing and flip it over, which I am allowed to do as long as I also flip this side over. But remember, you have to flip this all together. So we have to kind of treat this like it's all over 1 right now. And then we're going to flip that fraction. So what I have now is just a regular y equals 1 over negative 3x plus 1/3. Okay, this is a little bit gross. It's technically correct, but it's gross, right? Because we have fractions inside of fractions, and these multiple choice answers would never dare let you keep a fraction inside of a fraction. We should, by the way, right now be able to cross off a and b, because we know there's nothing here that has to do with square roots, right? We're really down to these two, and you might be able to reason it out from here, but mathematically, here's what I can do to fix this problem. On the bottom, if I were to multiply through by something, and we'll talk about that something here, I could get rid of that 1/3. I can make that not be a fraction anymore. And what I would want to multiply by is that denominator. So I'm going to take this entire denominator and multiply by 3, which is totally okay as long as I also multiply the top by 3. So that would do this. Up on top, 3 times 1 is 3, over, and on the bottom, distribute here, and I get negative 9x, and then 3 times the 1/3 gives me a much prettier plus 1. Okay, they just wrote their answer a little bit backwards, but it's 3 over negative 9x plus 1. That's the same as 1 minus 9x, so my correct answer here is C. Okay, let's move on and talk slope fields in number 2. It says, which of the following represents a slope field for the differential equation? Okay, so I want you to remember, because we seem to struggle with these problems, this is talking about, this is the equation that generates all the slopes, right? So if I was to say, for example, that this was going to be my answer, I should be able to pick any point off this graph and plug in the xy coordinates here, and it would give me the slope of that little line that you see there in the slope field. So we could go through and just start picking random points and checking them and trying to see, which ones can we eliminate. But there's some things I like to look for. I like to look for zeros, first of all, because zeros make my life easier. So in, for example, this slope field, I am seeing that when, what's happening here? When x equals negative 1, I end up with a slope of 0, right? All of these are 0. So that would mean that if I were to take negative 1 and plug it in for x right here, I should get a 0 out as an answer. That's not going to work, right? If I put a negative 1 on the bottom, that's not going to make this thing equal 0. So right there, that's enough for me to say A is not correct. Okay. For B, where do I see some zeros? So I see some zeros here. That's at y equals negative 1. Okay, so then I ask myself, if I put negative 1 in for y, does this value come out to equal 0? Well, putting a negative 1 on top is also not going to give me a slope of 0, so I'm also knocking off letter B. Okay, where do I see zeros with this next one? This next one's kind of tough. I'm seeing it at like 1 negative 1 and 2 negative 2 and 3 negative 3, which I could take any one of those and plug it in here and here. And if it doesn't give me 0 as an answer, then this isn't correct, right? So if I were to say, 2 negative 2, if I were to put a 2 for x and a negative 2 for y, is that going to give me a 0? It is not. So I am crossing off C as well. And last one, I am seeing some zeros. Gosh, I don't think those are zeros there. I don't know if I guess I'm seeing zeros along the x-axis. Sorry, those are hard to see. But I am seeing zeros along the x-axis. That's when y equals 0. So ask yourself, if I put 0 in here for y, will that equal 0? Well, yeah, it sure will. And right now I'm feeling pretty confident about that because I knocked out all 3 of these. But just to be safe, or maybe there was like another option that could have worked and I had to like now make a decision, let's look at some other things. So you see the middle here? Okay, that's when x equals 0. And I'm not seeing slope field lines at all. They're not zeros, right? They're just not there. That means undefined. So when y equals 0, I should be getting a slope of 0. When x equals 0, I should be getting a slope of undefined. So let's verify that. If I were to put 0 in here for x, would I get an undefined value? Yeah, I sure would, because I'd have something over 0, right? And so I feel pretty confident about choosing letter D here. Usually the zeros are enough. Sometimes you have to look at things like when is it positive, when is it negative. But usually the zeros are enough to at least knock out a couple of your choices. Okay, let's head to the next page. Okay, here's another one where I've been given a slope field and we have to match it to an equation. So I'm going to use kind of the same process. So for example, the first thing I'm noticing is I'm seeing zeros along here. Now, I helped somebody else with this problem and this really threw me off because I wanted to call this -2. But if you look at how this graph is numbered, down here it says -3. So this is counting by 0.5s, okay? So this is really -1. This is -2, and then this down here would be -3. So this is when y equals -1. So what should be happening in whichever one of these is my correct answer is every time I plug -1 in for y, I should get 0 out as an answer. So let's go through here. If I put -1 in for y here, this parenthesis becomes a 0. So this would automatically equal 0. So A is still in the running. A is a possibility. If I put -1 in for y here, I'll have -1 times whatever this is. That's not guaranteed to be a 0, right? I mean, I guess it could be depending on what x is, but I want something where when I put -1 in, like here, without a doubt, it's going to equal 0. And that doesn't happen with B, so I'm crossing that one out. This one doesn't even have a place to put y in. And so just so you kind of recognize this, anytime your differential equation only has an x in it, that means that if I were to go to any x value, I should see the same slopes running up and down. Like these would all run in columns, okay? I'm not seeing that here. I'm not seeing all the same slopes going up and down. They definitely change. And so that right there is enough to tell me that C is not the correct answer. And then let's talk about D here for a second, because with D, if I put -1 in for y, I do get 0 out as an answer. So right now I'm thinking that's a possibility. But just like what we talked about with this one, if it only has a y in it, then that means I should be able to stand on any y value, and all of those slopes going left to right should be exactly the same, because they don't change with the x value. They only change with the y value. And I'm not seeing that. So I'm feeling pretty good about crossing off letter D. But just in case that's not enough to convince you, let's try one more thing. I'm also seeing some 0 slopes here in the middle, right? Down the down the y-axis. That's when x equals 0. So if you look at letter A, if I put 0 in for x, I do also get 0 out as an answer, right? This one doesn't even have a place for me to plug 0 in for x. So I'm going with A. Okay, this next one, number 4, I think was formatted kind of badly on your paper, and I apologize for that. This is definitely a trickier one with the separation of variables, so let's talk about that. So what I would do here is we need to be able to get the x and the y separated. This is an x minus y here. And so I want you to think about that as addition. I want you to think about that as like an x plus negative y. And we talked about how when you add exponents, the reason you would add exponents is if you were multiplying two powers together. So I'm going to take this thing and rewrite it as e to the x times e to the negative y. Okay? That's what this is really equivalent to. And if you think about putting that back together again, this should make sense. And then if I have a negative exponent here, this thing is really the same as 1 over e to the y. Okay, and then I want to separate variables, meaning I want to move this to the other side, right, with the dy. So when I do that, since this is on the bottom of this fraction, I would multiply by the e to the y to get it to the other side. So when I first separate variables, I'm going to have this, e to the y times dy equals, and then left over on this side, so I move this to the other side, I just have e to the x, and I'm going to multiply the dx over there, so I have e to the x dx. Okay, this one actually works out really nicely. Integrate, integrate. Okay, the antiderivative of e to the y is just e to the y. And the antiderivative of e to the x is just e to the x. Now, we do get a plus c in here, and this is always where I pause and I go find what that c value is using my initial condition. This is x, this is y. So what this is saying is e to the power of y, which is natural log of 3, is equal to e to the power of x, which is 0, plus c. Okay, e to the natural log of 3 is just equal to 3. That's one of those properties of e that you should be really familiar with. And then remember, e to the 0 does not cancel out. This is really a 1 plus c. And then subtract, and I end up with 2 for my c value. That's going to go right back in here. Okay, so starting from there again, e to the y equals e to the x plus 2. And now I want to figure out how to get this y by itself. So since the y is up in the exponent, to move it down, what I would probably want to do is take a natural log, which is fine as long as I take a natural log of this side. Well, natural log of e to the y, that's just y. This side, I can't really simplify that at all. I would just leave it as natural log of e to the x plus 2, and I haven't really looked yet, but I'm hoping that's one of my answer choices. Natural log of e to the x plus 2, letter D. Okay, and one last one. This function is a solution to which of the following differential equations? So these are differential equations because they are equations involving derivatives, okay? And it wants to know which one of these has this as a solution. That means which one of these equations could I plug this function and its derivatives into and have it come out to be true? So I guess the first thing I would do here, because I clearly need y double prime and y prime, is I would find those things. So I have y prime, chain rule here. So y prime would be 2e to the 2x, and then minus 3x gives me a minus 3, and the plus 4 goes away when I do a derivative. And then y double prime, multiply by a 2 again, so this comes out to be a 4 e to the 2x, and then that minus 3 goes away. Okay, with these ones, we always just hope that we're going to find our answer in the first couple. We're hoping letter D is not the right answer. Now watch, that's what it's going to be. I don't know what it is. But I'm going to test all of these. So here's me testing letter A. Y double prime, so 4e to the 2x, minus y prime. Now be careful because this y prime has more than one piece, so when I subtract it, I need it like this, in parentheses, minus 3, plus 6 equals 0. Now I could go through and do some number crunching here, but I can see already that this is not going to cancel out, right? That 4e to the 2x minus 2e to the 2x does not cancel out. And then I'm subtracting a negative 3, which is really adding a 3, adding another 6. There's no way all of that is going to come together and make 0. So I feel pretty good about axing that one out right now. Like I said, it's going to be D. I don't really know that yet, but okay, y double prime, 4e to the 2x minus 2 times y prime, so 2e to the 2x minus 3 minus 6 equals 0. Okay, this one has some potential because this negative 2 is going to get distributed, right? So 4e to the 2x, when I multiply by that negative 2, I get minus 4e to the 2x. Negative 2 times negative 3 gives me a positive 6 and then a minus 6. Okay, so I'm seeing these two cancel and these two cancel. And so, yep, this does in fact equal 0, so I'm feeling pretty good about B. If you had time to burn and you were nervous that your answer was wrong, you could go through and check it in C and D as well. But that's what you're looking for. It's just a place where you can plug these derivatives in and have it come out to be whatever the equation says it should come out to be. Okay, so hopefully you've enjoyed that little journey back in time to Unit 7. That's just a quick overview of some of the things that were in Unit 7. We're going to look at some FRQs that deal with some of these topics next. But it would be really good to have this sort of refreshed in your mind before we go into that. So hopefully this helped, and I hope you have a great day.